Okay, so hello everyone, welcome back to my maths homework. Let's do the first question. If a minus x upon px is equal to a minus y upon qy is equal to a minus z upon rz and pqr are in an AP, then prove that xyz are in harmonic progression. Fine. So we are given that a minus x upon px, which can also be written as a upon x minus 1 upon p, is equal to a minus y upon qy, which can also be written as a upon y minus 1 upon q, and this can be written as a upon z minus 1 upon z. And now I'm going to call this as something, say lambda. So from this I can say that a upon x minus 1 is equals to p lambda, a upon y minus 1 is equals to q lambda, and a upon z minus 1 is equals to z lambda. Fine. Now we know that PQ and sorry, this is supposed to be R. Uh, yes, this is supposed to be R. Sorry. So over here you will have yes, A upon Z minus 1 is equals to R lambda. We know that PQ and R, this is an AP, which means that P lambda, Q lambda, and R lambda is also an AP, which means that A upon Q minus 1, A upon y minus 1, and a upon z minus 1, this is also an AP. Fine. But now I can add 1 to this, right? 1 to every term, and still it will be an AP. Okay, now I can divide uh, all of the terms by a, and it will still be an AP, which means that 1 upon x, 1 upon y, and 1 upon z, this is an AP. That means that x, y, z are in harmonic progression because the reciprocals are in arithmetic progression. Fine. Let's go to the next question. The next question is, if x is equals to the summation from n equals to 0 to infinity of a power n, y is equal to the summation from n equals to 0 to infinity of b power n, and c equals to summation from n equals to 0 to infinity of c power n, where a, b, c are in AP. Okay, and uh, the magnitude of a is less than 1, the magnitude of b is less than 1, and magnitude of c is less than 1, then prove that x, y, z are in HP. Okay, so we can use the formula x is equals to a upon 1 minus r. Here the first term is going to be, when you put n equals to 0, you get 1. The ratio is going to be a. Okay, then you have y is equals to 1 upon 1 minus p, and z is equals to 1 minus 1 upon c. Now we are given that a, b, c are in AP. Fine. By the way, we can also write this as 1 upon x is equals to 1 minus a, and then 1 upon y is equals to 1 minus b, and 1 upon z is equals to 1 minus c. Okay, cool. Now we know that a, b, c, these are going to be in an AP, which means that minus a, minus b, and minus c, this is also an AP, with just the common difference being the negative of what it was over here. And then that means that 1 minus a, 1 minus b, and 1 minus c, this is also an AP. But look over here, 1 minus a is 1 by x, and then this is 1 by y, and this is 1 by z, which means that 1 by x, 1 by y, and 1 by z, this is an AP, which means that x, y, and z are in a harmonic progression because the reciprocals are in arithmetic progression. Fine. Let's go to the next question. So the next question is, if x, 1, and z are in AP, okay, and x, 2, and z are in GP, then prove that x, 4, and z are in harmonic progression. Okay, cool. So these three numbers are in AP, which means that 2 times of the middle term, which is 2 into 1 is 2, is equals to sum of the last and first term, which is going to the first and last term, which is going to be x plus z. Okay, over here these three terms are in GP, which means that 2 squared is going to be 4 is equals to the product of these two, which is going to be x into z. I think we can just find x and z now. Okay, So let's multiply this equation by let's say x. Okay, so that will give me 2x equals to x squared plus xz, but we know that xz equals to 4, so 2x equals to x squared plus 4, which means that x squared minus 2x plus 4 is equals to 0. Now this is slightly not good because b squared, 2 squared is going to be 4 minus oh shit, this is not, something is wrong. Yeah, okay, so x and z does not necessarily need to be real numbers, I think. Okay, we just have to prove that x, 4 and z are in NHP. Fine. So to prove that x, 4 and z are in NHP, we basically have to prove that 1 over x, 1 over 4 and 1 over z, these are in an AP, which means that 2 times of the middle term, which is going to be, well, half, is equals to the sum of this and that, which is going to be 1 by x plus 1 by z, but that can be written as x plus z upon xz, but x plus z is 2 and xz is 4. So yes, this is completely correct. These are in NHP, though we did not find what those real numbers actually were that this happens. Maybe there are no real numbers such that these equations are satisfied at the same time, but whatever. Okay, the next question is, if a1, a2, a3 all the way till a2n and b are in an AP, and a, g1, g2, g3 all the way till g2n and b are in a GP, and h is the harmonic mean of a and b, then prove that a1 plus a2n upon g1 into g2n plus a2 plus a2n. Okay, so it's that kind of a question. So this sum, this is going to be equal to 2n upon h. I can already sense that every term is going to be the same thing, because here you are going up by 1, here going down by 1. So in effect this sum is still the same, and here you are going up by 1 and going down by 1, so the product is still the same because these are in GP and these are in AP. Okay, whatever. Let's just do it now. Fine, so a1 plus a2n, that's going to be equal to a plus b. Then a2 plus a2n minus 1, that's going to be equal to a plus b, and it keeps on going like that. And then you have g1 and g1 and g2n, that will be a into b, and then g2 and g2n minus 1, that will be a into b, and this keeps going like that. Fine, it goes on till an and an plus 1. Okay, yes, I think that is correct. Right, so 1 plus 2n plus 1, that gives me 2n plus 1, 2 plus 2n minus 1, that gives me 2n plus 1, n plus n plus 1 gives me 2n plus. Okay, this is completely correct. Yes, correct. So the net effect is that you just have a plus b upon ab everywhere. Well, how many of them do you have? Here's one, here's another, it keeps on going like that. So you are going from 1 to n over here, so there are going to be n of these. Fine, and let's just calculate the harmonic mean as well. So suppose 1 by a, 1 by h and 1 by b, these are going to be in a AP, because okay, fine, which means that 2 upon h is equals to 1 by a plus 1 by b. I think that's it. So this can also be written as 1 by a plus 1 by b, just splitting this fraction into n. Okay, but 1 by a plus 1 by b, that's going to be 2 upon h. This is h, not n. So this is going to be 2 times of n upon h. This was easy. Let's go to the next question, which is, if the m plus 1th and n plus 1th and r plus 1th terms of an AP are in GP, and m and r are in harmonic progression, then find the value of the ratio of the common difference to the first term of the AP. Wow, this seems complicated. Okay, let's use the first information, which is m plus 1th term, n plus 1th term and r plus 1th term of an AP are in GP. Okay. Well, here's the thing, that we know that a m plus 1, that's going to be equal to a plus m times the difference, and then a n plus 1, that's a plus n into d, and then a r plus 1 is going to be a plus r into d. Okay, and these terms are in a gp. Oh, fine. So let's take the ratio of them. Fine, that's the only thing which we can do right now. Let's just use that thing. So square this, you get a squared plus 2 a n d, and that's amazing. Fine, so n squared d squared, that should be equal to the product of these two. So you will get a squared plus, you will have r plus m, I think. Yes, so a into r plus m into d, okay, plus mr d squared. Fine, so this cancels. You have another d cancelling out. Okay. And what else? So you will have, guess what, a into r plus m minus 2n, and then plus, oops, sorry, just write it somewhere else. Okay, just erase this. Okay, so you will have a into r plus m minus 2n plus d into mr minus n squared. This is equal to 0. Okay, cool. The next piece of information here given is m and r. These three are in HP. Okay, fine. So these three are in HP, which means that yeah, 2 upon n is equals to 1 upon m plus 1 upon r, something like that. I think this can be done, no problem. Just divide by something, that will help me. Fine, so okay, I think this can be done pretty easily. So first of all, you have that r plus m upon mr is equals to 2 upon n. So r plus m is going to be 2mr upon n. Fine. Now I can substitute this in this equation. All right. So that will give me something. This is equal to 0. So this gives me a into, well, r plus m can be written as, yeah, 2mr upon n minus 2n. Oh yes, this is going to be nice. Mr minus n squared is equals to 0. Just erase this now. Now when you cross multiply this, you get a 2 out of it, and then you also get 1 upon n, and then you have this a, and then the remaining stuff is mr minus n squared. But look, it's common, right? It's common in both of them. So instead of writing it over here, I will just write it like this, plus d into mr minus n squared is equal to 0. Now there are two possibilities, that mr is equals to n squared. That can be one of them, though I don't think that's going to happen. We have to find the value of the ratio of the common difference to the first term of the AP. Oh, come on, this is weird. I don't think this is going to happen. If this was supposed to happen, then m, n and r are in HP as well as it is like they are in GP. More like they are equal, something like that. Okay, though I do not think these are going to be in GP, so there might be some possibilities, but we will do that case later. So now we just conclude that 2a upon n plus d is equals to 0. Fine. We have to find the value of the ratio of the common difference to the first term of the AP. But we don't know what this thing is. We don't know the value of n yet. Okay. This is weird. I was not expecting this. It might be possible that, yeah, maybe we didn't do it correctly. That could be a possibility. Okay. Fine. Obviously this n we do not know, but whatever, we'll just deal with this. Fine. So m, n and r are in, yeah, it should be it. That should be it. Let's just divide this by d. I think we are going correct on this, and even if we are not, we will just do it later. So this is going to give me 2 into a upon d upon n, obviously, plus 1 is equals to 0, so it's going to be minus 1, and then you will have a upon d is equals to minus n upon 2. That is weird. Well, whatever, that's how it works. Okay, I'll just do this question later because this seems kinda not so good. Okay, if the sum of the roots of the quadratic equation ax squared plus bx plus c equals to 0 is equal to the sum of the squares of their reciprocals, then prove that a upon c, b upon a, and c upon b are in a harmonic progression. Fine. So the sum of the roots is going to be alpha plus beta, which is going to be minus b by a, is equal to the sum of the reciprocals of the squares, okay, which can be written as alpha squared plus beta squared upon alpha squared beta squared, which can be written as alpha plus beta whole squared minus 2 alpha beta upon alpha squared beta squared. But this can be written as minus b by a whole squared, is going to be b squared upon a squared minus 2 times of c by a upon c squared upon a squared. Fine. Just erase everything. Okay, well, that's going to be equal to, if we multiply by a squared, we will get b squared minus 2ac upon c squared. Okay, so you have this equation, minus b by a is equals to this mess, which can also be written as b by a is equals to 2ac minus b squared whole upon c squared. Fine. So now we have to prove that these are in a harmonic progression, which means that the reciprocals are in arithmetic progression. So c upon a upon b, and yeah, b upon c, these are supposed to be in a arithmetic progression. Fine. Now I can just multiply by a by c, abc, sorry, that will give me c squared b, and then a squared c, and then let's say b squared a. These are supposed to be in arithmetic progression. Maybe we are getting that. Okay, so c squared b is equals to 2a squared c minus ab squared, which means that c squared b plus ab squared is equals to 2a squared c. 2a squared c is equals to c squared b plus ab squared. Right, that's correct. So these are in an AP. This was easy. Let's go on to the next question, which is, you know what, let's just do this question once again. Even if you spend more time on it, that's okay, just do it now. So if n plus 1 and r plus 1 terms of an AP are in GP, fine. So the n plus 1 term is going n plus 1 term, that's going to be a plus n into d, that squared is equals to a plus m into d into a plus r into d, which means that a squared plus 2a and d plus n squared d squared, that's going to be equal to a squared plus, you got ad into m plus r. Fine. And then you have mr d squared. Okay, cool. So these cancel, one of the differences cancel, so that gives me d into, sorry, not d, this is supposed to be a, that gives me a into 2n minus of m plus r. Let's do it like this, maybe m plus r minus 2n will work better, minus 2n plus you have a d into mr minus n squared, that's supposed to be equal to 0. Okay, it's supposed to be equal to 0. Just write it over here, equals to 0. Fine. um, this is a and this is d. Okay, but now we are given that m and r are in harmonic progression, which means that 2 upon n is equals to 1 by m plus 1 by r, which means that m plus r is equals to 2mr upon n. So you can substitute that over here, so you will get a into, well, you can get 2a over there, and then you can get this thing. So mr minus n squared plus d into mr minus n squared is equals to 0. Fine. So either you will have that 2a upon n plus d equals to 0, which we already did once and we got the result from that, or you could have mr is equal to n squared. Okay, so if mr is equals to n squared and you have mn and r in a harmonic progression, which means that 2 upon n is equals to m plus r upon mn, sorry, mr. So 2 upon n is equals to m plus r upon n squared, one of them cancels, so 2n is equals to m plus r. Wow, that's weird, which means that, okay, that is creepy. Okay, maybe just square this. Yes, 4n squared is equals to m squared plus 2 mr plus r squared, I guess, and then we can subtract that from that. Wow, this is pretty creepy. This is also a gp, a hp, and nep at the same time. Wow, this is more like both of them are basically the same. That's not, no, that's like the only way in which this can happen, I guess. Is this real? Wow. So let's see what we can get. Let's use this and then substitute this value in that, I mean, like n equals to m plus r upon 2. Let's substitute this value into this equation and let's see what we get as m and r. So you will get m plus r upon 2 whole square. Just do it differently. Let's multiply by 4. So 4mr is equals to 2n whole squared is going to be m plus r whole squared. It's going to be m squared plus 2mr plus r squared. Fine. And just erase everything else. This is weird. Let's divide by m squared. Yeah, that should work. So 2r by m is equals to 1 plus, sorry, 4r by m equals to so 2r by m plus r by m whole squared, call this thing as x. So you will have x squared plus 2x plus 1 equals to this thing, so x squared minus 2x plus 1 equals to 0, so x equals to 1, which means that r should be equal to m. Wow. Which also means that n is also equal to r, so all of them are actually equal. Fine. So here if we assume that m, n and r are not all the same thing, that they are distinct, then we get the answer which we got before. Okay, the next question is, if the first two terms of an harmonic progression are 2 by 5 and 12 by 13 respectively, then find the largest term. Okay, so the first two terms of a harmonic progression are 2 by 5 and 12 by 13, which means that the reciprocals will form an arithmetic progression. So 5 by 2, and then you have 13 by 12, and then you have 1 upon the next term, call this a3, and then the next term, and then the next term keeps on going like that. That's going to be the arithmetic progression which we get after reversing the HP. Fine. Which means that the difference over here, 5 by 2, right? So multiply this by 6, that will give me 30 by 12 to 13 by 12. That's a jump of minus 17 upon 12. Fine. So every time we go to the next term, we add minus 17 by 12. So now we want to find the largest term, which basically means that we want to find the smallest positive term of this AP, so that when we reverse this, that gives me the largest term. All right, so there you go. We want to keep reducing this till we eventually get the smallest positive terms, which is in fact 13 by 12. See, if you add minus 17 by 12 to this, this becomes minus 4 by 12, which is negative. That's not good, which means that this is in fact the smallest positive term, which means like 12 by 13 is in fact the largest term of that HP. Fine. So if A, B, C are in GP, and A minus B, C minus A, and B minus C are in HP, then prove that A plus 4B plus C is equal to 0. Okay, A, B, C are in GP, so B squared is equals to AC, and these terms are in an HP. Okay, which means that 1 upon A minus B, 1 upon C minus A, and 1 upon B minus C, these are in an AP. Fine. So let's just multiply this AP by this thing, A minus B into B minus C into C minus A, because that will still give me an AP if you multiply by the same thing. So you will get a product of these two on over here. That will give me, well, let's see, C times B, BC minus C squared, and then minus AB plus AC. Fine. And similarly we get all the other results. Okay, let's write it a little bit more compactly somehow. Okay, whatever. So that's what we will be getting. And then we will get, when you take the product of these two, as AB and then minus C squared. Fine. What? So sorry, AB minus AC, and then minus B squared and plus BC, and the last thing which we get is, well, we get AB. Yes, no, sorry, these two are done. So the next thing is going to be when we product these two, so that will give me AC, put a line, AC, and then minus A squared. You have minus BC and plus AB. Fine. Let's see if there are anything which is common. Not seeing anything, but here's this is where we can use the fact that B squared is supposed to be equal to AC. So here you see that B squared, I'm going to replace this by AC. So these three terms are in a arithmetic progression. Let's see if we can cancel AC from somewhere. Okay, this is very weird. Maybe we can cancel some kind of factor from these. Over here you have, okay, this is not cool. This is getting more and more complicated. Fine. Prove that A plus 4B plus C is equals to 0. Instead of doing all this, let's just go by our usual method, and I should stop being creative now. So this term minus this term, which is 1 by C minus A minus 1 by A minus B, that's going to be equal to this term minus this term, which is 1 by B minus C minus 1 by C minus A. Let's do cross multiplication. So you get A minus B minus C plus A upon AC minus BC. Oh god, this is crazy. This is too much of a work. Okay, plus AB. This is the left hand side. Okay, I don't know what's happening. Fine. The right hand side is going to be, well, let's see, C minus A minus b plus c upon so you have minus bc, then oh sorry, not minus bc, plus obviously, so bc minus ab, and then minus c squared and plus ac. Fine, these two things are going to be equal. This can further be written as well. You have c plus c is 2c minus a plus b upon, okay, so bc minus ab minus c squared plus ac. Okay, let's kind of write it on the top, that will give me more space. And then this can be simplified to, well, you have 2a minus b minus c upon, you have ac minus bc. Not getting a good feeling about this. This can be pretty complicated, so let's just forget about this. Oh god, this was not good. We need to think of something else. We have to prove that a plus 4b plus c is equal to 0. This is weird. I don't know how to do this. Maybe like 2 upon c minus a is equals to 1 upon a minus b plus. Okay, let that be. You know what? Let's say that b equals to a times r and c equals to a r squared. So this a minus b, that becomes a into 1 minus r. Fine. Then c minus a, that becomes, well, a into r squared minus 1, and b minus c becomes a into what? So you have r over here and r squared over there, so r into r minus r squared. These are supposed to be in a harmonic progression. Okay, cool. Which basically means that these three terms are also in a harmonic progression. Now we can factor out a 1 minus r from these, which means that 1, and then when you divide by 1 minus r, you get, well, negative of r plus 1, and then divide by 1 minus r, you get r. These are also supposed to be in a harmonic progression. Oh, that's nice. That was really nice. Which means that 2 times the reciprocal of this thing, which is going to be minus 2 upon r plus 1. That is the sum of the reciprocals of these two. So 1 plus 1 upon r. Okay, this looks easy. So that gives me minus 2 upon r plus 1 is equal to r plus 1 upon r. That gives me minus 2r is equals to r plus 1 squared, which is going to be r squared plus 2r plus 1 of, we are very, shit, what happened? We are very near to our final result. So that gives me r squared plus 4r plus 1 equals to 0. Man, this method is really cool. Just assume b as ar and c as ar squared. That really does the job. Okay, now just multiply this by a. So that will give me ar squared plus 4ar plus 1 equals to 0. So, sorry, plus a equals to 0. But guess what? Ar squared is c. So you have c plus 4b plus a equals to 0. Is that what we had to prove? Yes. Okay, nice. So this does simplify a lot when you use b as a times r and c as ar squared. Okay, if x, y, z are in ap and ax, by, and cz are in gp and abc are in hp, prove that x by z plus z by x equals to a by c plus c by a. Okay, so x, y, and z are in ap, which means that 2y equals to x plus z. Fine. Ax, by, and cz are in a gp. Okay, which means that b squared y squared equals to acxz, and a, b, c are in hp. Okay, which means that, well, 2 upon p equals to 1 by a plus 1 by c, or yeah, so p equals to 2 into, you get a plus in the bottom, and you got ac over here. This is a better statement to use. Fine, so you got these three equations. Now we want to convert these three equations into this thing. Okay. Oh, so there is no y over here. Maybe we can try eliminating y. Okay, so maybe use this thing uh, and substitute it in this thing. Fine, let's multiply by 4, so that gives me b into 2y whole squared is going to be x plus z whole squared is supposed to be 4acxz. Okay, so that will give me something. Fine, but I don't think that will be it, because you will have this extra b over there and there is no b. So maybe you can try substituting this thing. So that gives me 2ac upon a plus c into x plus z squared is equals to 4ac xz. Oh, so 2ac cancels, just have a 2 left over there. So what does this give me? That gives me well, what, I think something is weird over here. So oh shit, we're supposed to be doing b squared over there. Mm-hmm. That's a big problem. Sorry. It's supposed to be b squared. Fine. Which means that this is going to be 4ac squared. Okay. Upon a plus c whole squared is going to be equal to, oh sorry, into x plus z whole squared. X plus z whole square, this is going to be equal to this thing. Okay, now you can get a 4 out of them and an a out of them and c out of them. Fine. This is more like, okay, this is like this thing, a plus c whole squared upon ac, just taking the reciprocal. That's going to be equal to x plus z whole squared upon xz, right? Putting that over there and then taking the reciprocal. Now we can expand these two. Okay, that will give me a squared plus 2ac plus c squared upon ac is equals to x squared plus 2xy, sorry, 2xz plus z squared upon xz. Okay, now let's break off this fraction, so that will give me a upon c plus c upon a plus 2 is equals to x upon z plus z upon x plus 2, and then these will cancel. So yeah, that's exactly what we had to prove. Easy. Let's go to the next question. So if a, b, c and d are in a harmonic progression, then find the value of, oh, a power negative 2 minus d power negative 2 upon b power negative 2 minus c power negative 2. Okay, there are negative 2 powers is supposed to be reciprocals. Hey, we already know that the reciprocals are in an arithmetic progression, so maybe we can use that. Okay, oh, I think yes. So let's say that a power minus 1 is x, not x. Yeah, let's say this is capital A. B power minus 1 is capital B. C power minus 1 is capital C, and D power minus 1 is capital D. So you will have A, B, C, D in an AP. Okay, so A, B, C, D is AP, and you are supposed to find the value of this thing, which basically is a squared plus b squared upon, oh sorry, minus b squared, a squared minus b squared upon sorry, a squared minus d squared, okay, upon b squared minus c squared. Okay, fine, maybe we can factor this out, so that will give me a minus d, which is like 4 times the difference. Okay, fine, upon b minus c into a plus d upon b plus c. Here's the thing, that b plus c and a plus d, these two are the same thing, so that cancels, and a minus d is 4 times the difference, while b minus c is just 1 times the difference, so this turns out to be 4. Easy. This was easy. Let's go to the next question. So find the 7th term of the sequence 1, 2 and 1/3. Oh, 2 and 1/3 is going to be 7 by 3, and then minus 7. Okay, and then this thing minus 1 and 2/5. Wow, so 1 and 2/5 is minus 7 by 5, fine, and dot dot dot. As all of these questions are somewhat related to harmonic progressions, maybe we should try taking the reciprocals. So 1 3 by 7, minus 1 by 7, and minus 5. Oh, so yes, all of them have a common denominator. Okay, let's just write this as 7 by 7, and that will make it completely clear. So you go with a jump of 4 by 7, I mean minus 4 by 7 from here to here, then minus 4 by 7, so you get minus 1 by 7, and then minus 4 by 7. That becomes this thing. We have to find the seventh term, which will be basically 7 by 7 plus 7 minus 1 is 6. 6 into the common difference, which is minus 4 by 7. That's going to be 7 minus 24. Fine. 7 minus 24 is minus 17, I think. Yes. Yeah, sure. Upon 7. Fine. So now I just take the reciprocal of that. So that gives me minus 7 upon 17. This was easy. So the answer of this question is minus 7 upon 17. If an is a sequence in harmonic progression with a2, is equal to 1 by 2, a1 is equal to sorry, a5, okay, a5 is equals to 1 by 11. So these are in a harmonic progression. Then find the value of 1 upon a1 plus 1 upon a2 plus 1 upon a3 all the way till 1 upon a20. Oh, this looks easy to me. So an is a harmonic progression. That means that 1 upon an, this is this is an arithmetic progression. Sorry, this is an arithmetic progression. Okay, so let's call this as capital an. Okay, so it will have capital A2 is 2, capital A5 is 11. Okay, that means that 5 minus 2 is just 3. So 3 times the difference is 11 minus 2, which is 9, which means that the difference is 3. Okay, that's nice. And then the second term is 2, so that means that the first term is going to be, when you subtract 3 from it, you get minus 1. First term is minus 1. Okay, we have to find capital A1 plus capital A2 plus capital A3 all the way till capital A20. Okay, that can be written as 20 upon 2 into capital A1 plus capital A20. Okay, or it can also be written as 2 times of capital A1 plus n minus 1 is going to be 19 into the common difference, which is 3. Fine, so that's going to be 20 by 2 into, well, 20 by 2 is just 10. Write it as 10. So 2a1, that is minus 2, plus 19 into 3, this is 27, to carry down 57. So this is going to be equal to minus 50, minus 55 upon, so minus 55 into 10, which is minus 550. Sorry, I mean, really, it's not supposed to be minus, it's supposed to be in positive, obviously. So this is 550. Fine, no problem. Let's go to the next question. So the next question is, if a, b, c everyone greater than 1 and x, which is a positive number, are in gp, okay, then show that log base a of x, log base b of x, and log base c of x are in a harmonic progression. Okay, so here we can use the rule that log base m of n can be written as 1 upon log base n of m. Okay, so log base x, this series, log base a of x, log base b of x, log base c of x. We have to prove that this is a harmonic progression. In other words, we have to prove that the reciprocals are in arithmetic progression. So we have to prove that log base x of a, using that rule, log base x of b, and log base x of c, these are in arithmetic progression. Okay, and we are given that a, b, c are in a gp, which pretty much means that the logarithms are going to be in an ap. So this is obviously correct. In other words, we have to prove that um, x to the a, yes, so the difference is the same, which means that a b c is supposed to be in geometric progression, which is correct, right? You just raise this to the x power, so that should give me a geometric progression where the difference in power is the same. Okay. Oops, what happened? Okay, this is done. And just write the value of this guy as well. This is 550. Okay. The next question is, if x x a and y are in arithmetic progression, and x b and y are in geometric progression, and x c and y are in harmonic progression. Wow. And prove that the quadratic equation ax squared plus 2bx plus c equals to 0 has equal roots. Oh, this should not be that difficult. So b is equal to, well, instead of writing b, we'll just write 2b is, oh come on, okay, 2b is equals to x plus y. Sorry, something went wrong. Oh, sorry. So these are in the arithmetic progression, which means that a squared is equals to xy. And then you have 2b equals to x plus y. And then you have, okay, these are in a hp, which means that what does that mean? That means 2 upon c equals to 1 upon x plus 1 upon y, which is equals to x plus y upon xy. So sorry, xy. C is equals to 2xy upon x plus 5, but guess what, xy is going to be a squared, so this is going to be equal to a squared, so 2a squared upon x plus y is 2b. Okay, that's nice. That means that a squared is equals to bc. That is just nice. So okay, that's cool. So a squared equals to bc, no problem. Where were we? Yes, we had to prove that we had to prove that this equation has equal roots. I think we got it messed up once again, so probably a squared is equals to bc. Doesn't look very correct. I think we got messed up somewhere. Just repeat everything. Okay, where were we? Okay, so xy is supposed to be a squared. Well, no, this is not correct, because x, y and a are in, oh shit, we got in trouble right now. This is supposed to be I got it flipped, so that's more like it. Fine, so this is going to be equal to, well, guess what, xy is b squared, and x plus y is, well, x plus y is 2a, so this is going to be b squared upon a. That means that b squared is equals to ac. Oh, okay, that's more like it. Yep. Like, I was wondering how did I get that a squared term and that b squared term got lost somewhere. Okay, so now we have to prove that, well, yeah, we have to prove that ax squared plus 2bx plus c equals to 0 has equal roots. So the discriminant of this quadratic is going to be 4b squared minus 4 into a into c. That is supposed to be 4 into b squared minus this is the discriminant, minus ac, but guess what, b squared minus ac is 0, so this is going to be equal to 0, which means that this equation has equal roots. Oh, this was easy. Let's go to the next question, which is where is it? Okay, you have the pth term of a harmonic progression be q and the qth term be p. Then show that its p plus qth term is p plus q. Oh, okay, nice. So the pth term of harmonic progression is bq, which means that the pth term of the corresponding arithmetic progression which you get when you reverse the harmonic progression, that will be 1 by q. So a plus p minus 1 into that common difference, that is supposed to be 1 by q. and then similarly you have a plus q minus 1 into d is supposed to be 1 by p. Okay, then we have to find the p plus qth term. Okay, this should not be that difficult. This is supposed to be equal to p plus q. We have to find the p plus qth term. This is going to be, so the p plus qth term of the corresponding ap, that will be a plus p plus q minus 1 into the common difference. Okay, what can we do with this? What can we do? Maybe you can multiply by q. That will help. Oh, this is very weird. Okay, fine, let's multiply this equation by q and this by p. Hopefully that will give me something, and then we can subtract it. So on the right hand side we will get 1 minus 1 is equal to 0. Then you get a into q minus p, and then you will have that pqt and then pqt, that those get cancelled, and then you have minus p into q minus p. That should be equal to 0, but because we are assuming that q is not equal to d, okay, yeah, that means that a is equals to d, because q minus p is not 0, so a minus d has to be 0. Okay, so either q equals to d or q equals to p or a equals to d. I'm going to go with the other one, which is a equals to d. Okay, then this is going to be pretty easy. Fine, so instead of writing it like this, let's write it as a into p plus q, right? And then over here let's just write it as a into p equals to 1 by q. Oh, that is so sweet. And then a into q is equals to 1 by p, so just add them up. Yep. What did we have to prove basically? Where is it? It's p plus qth term. That is p plus q. Wait, something is wrong in this, because it's supposed to be 1 by q plus, oh shit, something is completely wrong. Yep, it's not going to work like that, because even if you add them up you get 1 by p plus 1 by q, and then when you take the reciprocal of that thing, that will become 1 upon, oh shit, that will not be good. It will not be p plus q. Okay, so where do we go from that? I don't know. I don't know. This is weird. I will do it later. Okay, the next question is, if a, b, c are in ap and a squared, b squared, c squared are in harmonic progression, then show that c equals to a plus b. Okay, nice. So a, b, c are in ap, which means that 2b equals to a plus c, and a squared, b squared, c squared are in harmonic progression, which means that 2 upon b squared equals to 1 upon a squared plus 1 upon c squared. Okay, which means that a squared plus c squared into b squared, that is supposed to be equal to 2 times of a squared c squared. Okay, now this multiplies by 4, so that will give me a squared plus c squared into 2b whole squared. It's going to be a plus c whole squared, that is supposed to be equal to 8 a squared c squared. Wow. Okay, yeah, almost everything is squared over here. Okay, fine, so just expand this. Give me a squared plus c squared into a squared plus c squared plus 2ac. Oh, this is nice. Yes, this is nice. Let's see what we get. Let's just erase this. Is this supposed to be 2a squared c squared? Yes, that is supposed to be like that. Fine. Yeah, I think we are going correct. Yeah, this is supposed to be correct. Okay, yes, so let's go to the next part, which is when we simplify this. Okay, yeah, so call this a squared plus c squared as x, capital X maybe, so you will get x squared, and then call this 2ac as y, So over here you will have xy. This is supposed to be, well, 2 into y squared. Yes, that gives me uh, like x by y whole squared uh, plus x by y minus 2 equals to 0. Fine. So now let's call this x by y as z. So we will get z minus 2 in, sorry, z plus 2, z minus 1 equals to 0. So z equals to minus 2, but remember what z was. Z was basically x squared, so, sorry, not x squared, a squared plus b squared upon 2ab. And where is it? Okay, so either this is equals to minus 2, in which case a squared plus b squared is supposed to be minus 4ab, which does not look very correct, because if a and b are positive, hey, we are not necessarily given that these are supposed to be positive numbers. But anyway, let's just go with uh, this possibility right now, because that's what we have to prove. So suppose z equals to minus 1, that gives me a squared plus b squared is equals to sorry, z equals to 1, that gives me a squared plus b squared is going to be equal to 2 times of ab, which means that a minus b whole square is equals to 0. So a equals to b. That's what we have to prove. Fine. Let's go to the next question. So the next question is how much time did I spend? Fine, not a big amount of time. So you have next question. Where is it? Okay, so if 5 numbers a, b, c, d and e are such that a, b, c are in ap, b, c, d are in gp, and c, d, e are in hp, if a is equals to 2, e equals to 18, then the values of b, c and d are, oh, fine. So a is 2. So you have 2b, and then you don't know the value of c, and then you have d, and then e is 18. Okay, and then a, b, c are in ap. Fine, that means that 2b equals, I think we have done one such equation. The value of b and c and d are, okay, so 2b equals to, well, a plus c, but in this case it's only 2 plus c. These are in an AP. Then you have BCD in GP, which means that C squared equals to B plus D. Sorry, B into D. Okay, and then you have CDE are in HP, which means that 2 upon D equals to 1 upon C plus 1 upon E. But in this case, 1 upon E is 1 upon 18. Just simplify this further. So that gives me something upon 18c, then c plus 18 is equals to 2 upon d. That gives me, we have to find the value of b, c and d. Okay, well, you have the value of c squared. Fine. And then here you have something in c. Hey, guess what? Okay, so here's the deal. We are having d in c completely, and we are having b in c completely. Most likely you can just input those values in this equation to get value of c. That will be easy. So this gives me d is equals to, well, this thing, so 36c upon c plus 18. Okay, this is the first equation that you have, and then this is the other equation. B equals to c plus 2 upon 2. That's the other equation. And this is the last equation, c square equals to bd. So here's everything else. So you also have this equation, c square is equals to bd. Okay, let's see what we get from these equations. So c squared is equals to p, which is this thing, times d, which is this thing. So c plus 2 upon 2 into 36c upon c plus 18. Fine. So here's the thing, one of them cancels. Well, c can technically be 0, but here we had like Yeah, so C was included in a harmonic progression, which means it cannot be 0. Okay, and then this cancels with this 18, so you have C equals to 18C plus 36 upon C plus 18. That gives me C squared plus 18C is equal to 18C plus 36. Oh, this was easy. That gives me C equals to plus or minus 6. Okay, this minus 6 acceptable. Let's see. um, where is that GP thing? So C, D and E are in harmonic progression. B, C and D are in a geometric progression. Well, that should be it. Like, you have C is equals to plus or minus 6. Let's see what we get when we put it as plus 6 and when you put it as minus 6. And now that we have got value of C, the other thing will be pretty easy. So you have where is it? A, B, C are in AP. A we know already is 2. We don't know the value of B, and then C is plus minus 6. Suppose this is plus 6, then in that case B is supposed to be 4. Okay, then you have 4, 6 and D. Okay, B, C and D. This is supposed to be a GP, which means that 36 is equals to 4D, which means that D is equals to 36 upon 4, which is like, what's that? 36 upon 4 is 9. Yes. Okay, and then you have CDE, which is 6 and 9, and what is E? E is 18. These are supposed to be in a harmonic progression. Okay, so you should have 1 by 6 and then 1 by 9 and 1 by 18 as a harmonic progression. Let's see. So we just multiply this by 3. That will give me 3 upon 18 and then 2 upon 9. So 2 upon 18 and 1 upon 18 is a harmonic progression. Yes, completely correct. So C equals to 6 gives me these values. Okay, so this is 4, 6 and 9, the value of B, C and D, one of them. And then you will have C equals to minus 6. That will give me some other values. Okay, so you have A equals to 2. You don't know the value of B yet. And then you have C equals to minus 6. Okay, this is supposed to be an AP. Fine, which means that B is going to be, the sum of this is minus 4 upon 2, which is minus 2. Okay, that's nice. And then you have BCD, which is B minus 6. So B is just minus 2 in this case. Minus 2, minus 6 and D, these are in a geometric progression, which means that minus 2D equals to 36. So D is equals to minus 18, I guess. Fine. And then you should have well, CDE, which is minus 6 and then minus 18, and E, which is 18. You should have these in a harmonic progression, which means that the reciprocal of this is going to be minus 1 by 6, which can be written as minus 3 by 18, minus 1 by 18 and 1 by 18. This should be harmonic. This should be an arithmetic progression, and it is, because you go up by 2 every time. So yes, both of them work. What was that? Yes, it was supposed to be minus 18. I think it's minus 2. Well, whatever. So let's go to the next question, which is where is it? Okay, the fourth term of a harmonic progression is 3 by 5 and the eighth term is 1 by 3. Then its sixth term is going to be fine. So here's the deal. The fourth term of a harmonic progression, you have A4. Fine. So the reciprocal of that, that's going to be the fourth term of the corresponding arithmetic progression, which means that 5 by 3 is the fourth term. The eighth term is the reciprocal of this thing, which is going to be 3. So we have to find the sixth term. By the way, 4, 6 and 8, this is like you go from you add 2D and you get to A6, and then you add 2D once again and then you get A8, which means that these are basically in arithmetic progression. So A6 is the arithmetic mean of A4 and A8. So A6 is this plus that upon 2. So 5 by 3 plus this is going to be 5 plus 9, which is 14 upon 3 upon 2. That says 7 by 3. Oh, that's easy. So this is, oh sorry, this is the sixth term of the arithmetic progression. So the harmonic progression will have its sixth term as 3 by 7. Fine. Okay, if the roots of, oh, a lot of it is left. Fine, I'll just do this page and stop. um, if the roots of a into b minus c into x squared plus b into c minus a into x plus c into a minus b equals to 0 be equal, then show that a, b, c are in a harmonic progression. Okay, so a into b minus c into x squared plus, okay, the roots of these things are equal, which means that the discriminant is 0. Fine, which means that b squared into c minus a whole squared is equals to uh, 4 times of these things, which is 4ac into b minus c into a minus b, I guess. Then we have to show that a, b, c are in a harmonic progression. Fine. Let's do it. So you have c minus a whole squared. This might not be so nice. Okay, b squared into c squared minus 2ac plus a squared, that's like equal to b squared c squared minus 2ab squared c plus a squared b squared. This is the left hand side. Okay, that should be equal to the right hand side. The right hand side is 4ac into, let's see, ab and minus b squared, and then minus ac and plus, wait, what, minus ac and then plus bc, obviously that does it. So this is going to be equal to 4a squared b into c minus 4ab squared c, okay, minus 4a squared c squared, and then plus 4ab c squared. I think this is correct. Yes, this is correct. Okay, let's just erase this. So these two are supposed to be equal. Let's see if there are any common terms in this. This does look ugly. Are there any things which I can cancel directly? No, it doesn't look like that. Wait, what? Okay, it's 4a squared c squared. Fine, we have to do something about it though. So yeah, a b, okay, we can cancel one of them. Okay, so that will give me b squared c squared. Let's erase that once again. Okay, so when you simplify, you have b squared c squared nowhere, so you have b squared c squared, then plus ab squared c. I don't think this is the way they wanted us to do it. So discriminant is 0. We have to prove that a, b, c are in, this is most likely not the way. Show that a, b, c are in harmonic progression. Oh god, this is damn weird. What can you even do with this thing? Maybe we can divide by something, by ADC. Maybe that will help a little, or maybe not. Maybe that won't help. Oh, okay. Maybe we can do this thing. So you see, this is going to be c squared minus 2ac plus a squared, right? This thing. When we divide it by this thing, by ac, and then you can divide this by a b of this, like one b of them, so that will give me b minus c upon b, then a minus b upon b. Okay, that looks okay. Let's see what we get. So c upon a plus a upon c minus 2, that has to be equal to, you have 1 Did I miss something over there? No, most likely I didn't. Fine. So it's equal to, you have, oh, it's supposed to be 4 over there, I think. Yeah. So 1 minus c upon b. So 4 into 1 minus c upon b into 1, sorry, into a by b minus 1. Okay. Just hope something nice comes out. Fine. Erase this now. I don't know what's going to come, so let's just see what happens. C upon a plus a upon c minus 2 is equals to 4 into, let's expand this. So you will have a upon b minus 1 and then minus c upon b into a upon b, that is ac upon b. Okay, and then plus c upon b. Oh, okay, fine. So that gives me c upon a plus a upon c is equals to, well, you are having 4 into something upon p. Fine. I don't know where we are going with this. Maybe that's not the way, like, we should not have been doing it like that. Ah, come on, this is very weird. This is supposed to be minus 4 over there. That's going to give me plus 2. Oh, so that's nice. Okay, when you expand this, when you cross multiply this with plus 2, so you get a plus c whole squared upon ac. Fine. So this is minus 4, it goes over there, it becomes plus 2, and then this is equal to, this minus 1 is now gone. So you just have 4 into a upon b minus ac upon b plus this guy's 4 upon b into yeah, a minus ac plus c. Okay. This is very weird. um Fine, what do we do with that? Oh yeah, let's multiply by this thing, ac. That will give me something nice, most likely. So b, I definitely don't know if what I'm doing is correct. Yes. Sorry, it's supposed to be ac upon b squared. Ah, that's where we went wrong. This is supposed to be ac upon b, one of them is left over. Fine, so you do get this on our left hand side, and then over here you will have 4 upon b squared into ab plus bc minus abc, something like that. You have a plus c somewhere, and then you have this thing somewhere. Oh, this is okay. Let's multiply this by that. So that will give me ab plus bc whole squared is equals to 4 times of, we'll multiply by ac over there. Yes, so it would have been better if it was, if it was like having a b square over there. So ab into bc, right? That's what it is like. Oh, come on, this is very weird. It's supposed to be ab squared and bc squared over there. Well, I don't know about that. Let's do it right now. So this is going to give me b into a plus c minus that guy. Oh god, this is becoming very tedious now. Okay, I will do it later. I think I will do it later. Fine, I'm going to do this question later. Fine, I'll just stop right now.